Before we move into discussing the architectural enablers, I just want to revisit a couple of ideas we discussed earlier. So in the first lesson, we talk about the evolution of Internet of Things in a couple of different ways. First, from the network point of view, the second is more the product point of view. So in the network point of view, as you can see in this figure, we start off with connecting a couple of computers together and moving from that to connecting multiple computers around the world together. And then these computers are joined by the large number of mobile phones and also the kind of tablet devices. And then the social identities of people using social media came into the mix by having now the traditional computers, mobile phones, and the virtual entities of individuals are connected together. And then we move to the Internet of Things, where now more and more physical devices like vehicles, coffee machine, refrigerators, homes, and all these kind of devices are interconnected through the internet. So this is how we move through the Internet of Things from network to the current form. We can classify these IoT products into three different broad categories. So you can think about first one as embedded devices, the second one is connected devices, and then the third one is the IoT products or the IoT devices. So smart products has been existed for many years. Probably you have seen the embedded devices. For example, all the washing machines, they have a timer which has some kind of a embedded system which will tell you when they or which will stop the washing machine when it is done. So this is useful because if you are in a house, then the washing machine stopped and the bell rang, you can go ahead and take them out or do whatever you want. And then when we moved that into the connected products, these are over the last about 10 years, where if you take the same washing machine example, you now have a connected system where the smart home get a notification. You probably be able to start and stop remotely, or you can schedule it. So those kind of things. So you have now a companion device like a smartphone connected to your washing machine or any other home appliances. So they are connected, but their intelligence and the ability to working together is kind of limited. And then we talk about the Internet of Things. So Internet of Things brings these devices and services together. So if we take the washing machine example, now we are thinking about developing mathematical models and deploying them in washing machine at larger scale in a neighborhood to collectively save energy. Or you can say your priorities, saying that I don't care about the amount of money, I want to get this washed quickly. Or you need to wash slowly to save the quality of the clothes you are washing. Or you want to reduce the water consumption. So now the washing machines have become very complex devices where each component can be changed, like the water, the speed that the drum rotates. All these parameters are become configurable and they become variables. And then these variables can be put into mathematical models as individuals about your washing machine, or it could be like in a smart city scale where a bunch of neighborhoods putting their variables together and then calculating what is the best and most optimum way that everyone saves money. And then everyone's preferences are being considered and met. So this kind of shared large scale as well as very personalized ecosystem we call the Internet of Things. So Internet of Things could bring savings for individuals, or convenient for individuals, or it could be benefit to the larger ecosystem around a particular demographic area, or people are using similar kind of devices. Because if you know that if you look at the energy consumption, if everyone puts their washing machines or any kind of electrical appliances at the same time, it will increase the load for the energy grid, which is a significant issue. But if you automatically distributed them across a long period of time, that saves everyone's energy. But that kind of scheduling should not be a burden for an individual, because we don't want to invest our time to save energy for everyone else. But if the devices can talk to each other, can come up with a schedule that does not harm or go against the preferences of the individual owner, but also as a whole they can work together to save energy or reduce load on the grid, that would be a great thing. So that is kind of intelligence and cooperation are the ones that we're specifically looking in Internet of Things beyond just connected devices. If you search for trends, predictions, and numbers related to Internet of Things on the web, you can find many different graphs and figures that will show you how the number of devices got increased over time. So I have picked one of those figures that shows how the number of connected devices got increased over time. In this figure, you can clearly see that the number of laptop, PC-based computers, mobile phones, they are growing very slowly. But we are increasingly see both short range and wide range of IoT devices. Wide range in the sense more like LoRa powered, or is like short range Bluetooth power smart connected devices within homes, getting increased rapidly over the years. So this is a predicted graph, but rather than bogging down into the details, what we need to sort of get out of this is that there are a lot of short-range IoT devices are getting into the market, where they might not be directly communicating with internet, but they may be connecting through like Z-Wave, Zigbee, Bluetooth, all these protocols we are talking at a later stage of this course. But you need to know that these devices are getting more and more into our everyday lives. These are the 6 enablers of IoT. So when you talk about enabler, what we are talking about is what makes IoT an IoT. What technologies or what are the reasons IoT got established or being developed? Because the technology behind IoT has been developed for many years, or even many decades. So it is not something that happened overnight or in few years. So the technology was there, but there are few enablers come together at a particular time in order to get the idea of IoT off the ground and make it more useful to everyone. So the first one is the computing power. So as you know that increasingly we see very small devices are packed with large volumes of computation capabilities compared to the few years back. So every year we see that small devices getting more and more powerful. For example, the memory capacity is going up, the computational capacity going up. So in this figure, you can see a Raspberry Pi 4, which is a small computer, as we call single board computer, which is the size of a credit card, but it has pretty much a full-fledged computing capability. So you can use for everyday work, probably not for high-end gaming, but you can play small games within that Raspberry Pi computer. And then It also has input-output that allows you to connect to even multiple screens these days. So in this particular Raspberry Pi, it has the capability to connect two 4K displays, which is a significant computation capability. So one reason is increase of computer power. And then the second one is the miniaturization, more sensors and decreasing of cost. So as you can see that we can pretty much replace a traditional big desktop computer with this kind of credit card kind of size computer. And then we can see similar things happen in other microcontrollers where they are becoming smaller and smaller. In lesson 1, we talk about a use case where they have developed very, very small sensors and microcontrollers. And also the production cost of these sensors are going down dramatically, especially when the demand goes up and when these sensors are produced in large numbers, the unit cost goes down. This is the second enabler why IoT becomes quite popular. The third one is the battery and energy. So the battery and energy harvesting technologies has been receiving quite breakthroughs over time, recent past, where we now have certain devices where they can power from the signal it is getting without even having any batteries, which allows to deploy these devices and sensors in places that we don't want to go and replace. For example, it could be within your body, or it could be very remote area where you don't want to go and replace the battery, or is it impossible to do that? And also the other hand, there are small batteries that can pack a lot of energy that could also run for many years without replacing or recharging the batteries. So the technological development of batteries and energy sector has been the third enabler to this IoT movement. The fourth enabler is the communication capability. So in this course, we have dedicated a lesson to talk about the communication technology. But to introduce the technologies briefly, there are many different types of communication technologies has been developed and used. So there's no winning technology where the single technology works for all different use cases. But what we have is a bunch of different technologies could be ideal for different use case scenarios. So we can think about like Zigbee, LoRa, Sigfox, 4G, Wi-Fi, you pretty much know. Bluetooth is short range, Zigbee pretty much short range, dedicated for industrial purposes. LoRa, very small number of packets, but very long range. Sigfox also same. So there are many different technologies to pick and choose from. So you probably may have seen this in lesson 1 in different use cases. Different companies and people use different communication technologies within the IoT application. So one of the key challenges that you might face when you're designing is to actually pick the right combination, one or more technologies within communication technologies within your IoT application. So that is the fourth enabler. So when you have all these kind of low power, high bandwidth, low bandwidth combination of different technologies available to you, it allows you to create creative IoT applications that can be sustainable and useful for everybody. The fifth enabler is the development resources. Over the last decade, people have developed open source technologies where other people can easily adopt and use it. For example, in early days, programming a microcontroller was something that done by very specialized people who studied embedded systems. So most likely someone with electronic engineering background, they will write the code for the hardware. So it's not something that computer science student or computer scientist is going to do in the microcontrollers or single board computers. But now, because there are a lot of already written tools, you can think of as like Java, where people have written the language, and then most people have done the hard working of writing all the virtual machines and everything, and then you only need to write the code. Similarly, there are tool chain has been developed, and then on top of that, there are frameworks has been developed to make your life easier to connect to a sensor, read the data from sensors, use a data communication module. You can just put them together. There are a lot of tutorials online. There are a lot of open source hardware and software which everyone contributes, and then as a community, the development resources become more rich, and then people are more responsive. You can ask questions, so because everybody knows the subject, so there are many people who can help. Early days, it could be more like embedded system engineers. They might there are not many of them, so if you ask a question online, maybe nobody answers. But this thing changed because of the open source nature, and then everyone started contributing as a community. And then the development boards, like most of the companies like Intel, Microsoft, Google, they have their own IoT development board. Some successful, some not, but there are open source version as well. Most of the time, the development boards are like open source. Everyone can use, play around, and critique it, and then the next version come with a better technology. So all this cycle and ease of development help reduce the gap or the cost that is necessary to become or develop IoT applications. And then the last one, I little bit touched on the previous enabler, human cost. So as I said before, historically, programming IoT or any kind of electronic component was done by someone specialized. So you have to pay for them, expensive skill set. But this become the barrier become lower, because anyone can now become an IoT developer, because similar to web and mobile, the coding is fairly easier. It may not be easy as a web or a mobile, but it is getting the maturity that web and mobile development has now. It will certainly, over the next decades, it will reach to the same point that web and mobile development have today. So because this is now no longer a rare expertise, it reduces the human cost that you need to hire in order to develop your IoT application. So these are the 6 enablers help to kickstart this movement of IoT, and that is why you are specifically learning this, so you can contribute to the development of IoT in the future. This is a very important figure that explains the communication technologies that are available for you to use when you're developing an IoT application. I'm not going to detail into this diagram because we have a dedicated lesson on network communication technologies. But to briefly introduce you to the communication technology, basically they are divided into 4 areas: PAN, LAN, MAN, and WAN. As you can see from in the figure, blue color, red, and then orange and yellow. PAN is personal area networks, which means that you can use it for short range communication. So you can see RFID, NFC, low power PAN, and then Zigbee, Z-Wave, Bluetooth. So all these kind of technologies are very short range. Then you have the local area network, you have the Wi-Fi. And then when you move into the wider area network, you can see the cellular, 3G, 4G, 2G, and then you can also see 4G coming up, even though it is not in this figure. So what I want to point out is that depending on the application scenario, you can pick and choose from these wide range of protocols, where each of them has some pros and cons, which we'll discuss later in this course. Previously, we introduced you to a number of different IoT protocols, communication technologies, and protocols. Here we have a very small summary table. It does not contain all the protocols we discussed earlier, but these are the main kind of protocols mostly used within the IoT application. And then we have listed IoT verticals. That means that there are the sectors or the domains that we discussed earlier. But if you remember, when we talk about these domains in lesson number 1, I mentioned that different people name them and classify them in different ways. So if you find some disparities between the lesson number 1 and these categories, don't worry about that, because that is what it is. People classify these verticals and the domains in different ways, slightly different ways, but you will see very similar things like buildings, cities, meters, connected health. So we saw similar things in lesson number 1. And then based on that, we can see based on the what people have already developed, we can classify what are the common technologies, communication technologies are applicable to each domain. So I just want you to stop and have a quick look on how they have allocated. For example, if you look at connected health, it based on what people have developed, the cellular and the Bluetooth Low Energy is the most commonly used technology, which seems to be correct, because based on the use cases we went through, usually connected health has some kind of wearable or some device that is closer to the human or a patient. And then those devices are very low powered. So you need to have a low power protocol like BLE to get the data out of those devices and maybe put it to your mobile phone. And then mobile phone will connect it to the cloud platform using cellular. So it kind of makes sense. But that doesn't mean that you can't use any other technology. Of course you can. So this is a diagram or a table that summarizes the highly applicable and moderately applicable communication technologies against the IoT verticals.